The problem statement from GATE Physics 2010 reads as follows. The voltage resolution of a 12-bit digital to analog converter whose output varies from minus 10 volts to plus 10 volts is approximately. This is a multiple choice question. We have been given 4 options and only we have to find the correct one. Only one option is correct, by the way. Right. Since the question talks about resolution, let's pause a bit and we establish some basics of resolution. So in digital to analog conversion, what do we mean by resolution? So we have a digital input and an analog output, as the name suggests, right? And so these are the two digital inputs. There will be a minimum value, there will be maximum value. Correspondingly, there will be a minimum output and maximum output. Now we know for digital input the minimum input can be 0 and the maximum output for an n-bit digital input can be 2 raised to the power n minus 1. And so the range will be 2 raised to the power n minus 1, right? The maximum minus minimum. Similarly, on the analog side, there will be some corresponding voltage Vmin and there will be some corresponding voltage Vmax. And their difference would be Vmax minus Vmin. Now, please note that we are simply doing a mapping from digital input to analog output. We are not creating, we are not putting any power, we are not changing the value, we are just representing in a different way. So, the difference between maximum and min on input side should be equal to the difference between max and min on the output side. Hence, this 2 raised to the power n minus 1 should be equal to Vmax minus Vmin. So, what is a resolution? Now, resolution can be defined the minimum value that can be distinctly measured. The keyword is distinctly. So, below this, you cannot measure it accurately, right? So, that means that clearly means that this means a jump of 1 bit, right? So, let's say its value was something 0001. So, next would be 0010. This is a jump of 1 bit, right? Because 1 when you add it becomes 101, when you add 1 it becomes 10. So this is the minimum jump that the input can afford from green to purple. Correspondingly, the analog output will also jump from green to purple. So this is the minimum resolution, which is defined by the 1 bit change. And since we know 2 raised to the power n minus 1 steps are equal to Vmax minus Vmin, which we established here, using the unitary method, we can simply say 1 step equal to Vmax minus Vmin over 2 raised to the power n minus 1. And note that this is our definition of a resolution. Resolution is the 1 bit change. So resolution would be simply equal to 1 step, which is Vmax minus Vmin over 2 raised to the power n minus 1. Now, coming back to our problem, so we were given a DAC with 12-bit digital, with 12-bit input, right? And the range of output was minus 10 to plus 10. So what I'll do, I'll simply write this formula which we saw in the last slide. So we know that Vmax is given as 10 volts minus Vmin is given as minus 10 volts minus 10 divided by 2 raised to the power n. N is given as 12. There are 12 bits minus 1, right? So numerator will come out to be 20 divided by 2 raised to the 12. So 2 raised to the 12. I can say 10 divided by 2 raised to the 11, right? So I can also write it as 5 divided by 2 raised to the power 10. Why I do this? Because I know 2 raised to the power 10 is 1024. It's a good thing to remember, right? And I can round it off to, let's say, 1000, right? So I can say 5 approximately 5 over 1000, which is approximately 5 millivolts. So you see, I completely I did not even need to use the calculator. So which is good, because when you use calculator, the chances of error increases. But anyways, so we found the answer as 5 millivolts. So here we have B is the correct answer for this question. Thank you for listening.